Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imran bin Saifuddin and we are from CS25568 and this is our group project presentation for ITT640. Okay, this is our team members. The first is Abdul Shakir Imran bin Abdul Salim, and then it is me, Muhammad Imran bin Saifuddin, and then Muhammad Akmal Haikal bin Azhar. The topics that will be presented in our presentations are first introduction, and then literature review, and then plan design, result and analysis, and lastly the conclusion. Okay, for the introduction, in this chapter, we will explore the world of wireless local area networks, that is LANs, and then these networks are the backbone of the modern connectivity, linking devices without physical wires. Let's dive into the core of our project. Okay, for the background of our project is, it is located in CS2 buildings in KPPIM, that is College of Computing, Informatics and Mathematics. And the issue is poor Wi-Fi connectivity impacting student and faculty in computing, informatics and mathematics. Also, the goal is to enhance LAN to provide stable, efficient connectivity. Okay, this is the problem statement of our project. The challenges is security vulnerabilities, inconsistent speed, unreliable connectivity, and high user demand. And then this project aims to improve LAN security, reliability, and accommodate heavy usage in educational settings. For our project, we got three objectives. The first is designing the network, that is standard wireless LAN for the 3 floors. And then testing the design, that is computer simulation to evaluate network performance. And last, analyzing results, that is assessing test outcomes from improvements.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal Haikal bin Azhar. So I will continue to my part, which is literature review. It consists 3 parts. The first one is review of LAN technology. Second, review of hardware LAN. And the third one, review of software for LAN. Okay, now we go to review of LAN technology. So the first one, we will talk about LAN. So LANs provide users the freedom to move within the network range, maintaining connectivity. This characteristic makes LAN ideal for diverse environments such as office, home, and public spaces. So on this LAN, we need to use Wi-Fi protocol. So Wi-Fi protocol critical for ensuring efficient data transmission between devices. Between devices, the Wi-Fi protocol has evolved significantly. So basically, we use ITT802.11. So the standard for Wi-Fi protocols is standard. The advancement in standards like 802.11a, 11b, 11g, 11n, 11ac, and the latest 11ax Wi-Fi 6. The latest one is Wi-Fi 7. Reflect ongoing improvement in speed, range, and network performance. Okay, so we go to set 1, which is review of hardware WLAN. There are consists 6 points or 6 hardware generally. So the first one is access point. Access point are central to WLANs, acting as transceiver that enable wireless devices to access the network. Also, access point which hold the network Wi-Fi protocol 802.11.a, NAC, and AX, the new one. So the second one is WLAN controllers, manage multiple access points, simplifying configuration and maintenance and enhancing performance with features like seamless roaming and load balancing. So the third one is switches. Basically, switches are crucial in managing data traffic between access points and wired networks, improving network efficiency and supporting technologies like power over internet. So the fourth, routers. Routers integrate WLAN into larger network and the internet. They often come with embedded security measure and quality of service features for prioritizing data traffic. So the fifth, NIC or network interface card are individual system enable wireless connectivity to WLANs, supporting various Wi-Fi standard and ensuring device compatibility with WLAN infrastructure. So the last one is PoE injectors. power devices like access point through Internet cables, facilitating easier installation and enhancing capability of WLAN deployment. So some of the router or access point using PoE, we just put it into router or as I say earlier, switches to give the power and data through the single cable. Okay, the last one is review of software for LAN. So the first one is firewall software. Firewall software is essential for securing WLANs, protecting the network from unauthorized access and potential threats. The second one is anti-spyware tools are important for protecting WLANs against various types of malware, ensuring network safety. So the third one is network monitoring software, provides real-time insight into WLAN performance and network health, aiding in proactive management and troubleshooting. The fourth, anti-malware solution plays a significant role in detecting and blocking malicious software using technology like signature piece detection and behavioral analytics. So the fifth one, authentication and encryption protocols like WPA2 and WPA3 they are using in the Wi-Fi password are critical for secure data transmission in WLANs. So the last one is just basically regular firmware and software updates for all the software I taught earlier are vital for maintaining the network security, efficiency of WLANs, addressing vulnerabilities and introducing new features.
Okay, now we in WLAN design in network requirement. So this is the floor 1, floor 2 and floor 3 network requirement. We will start with the signal strength. So signal strength, a minimum of at least negative 70.0 dBm ensures a strong and reliable connection for wireless devices. This helps prevent issues like signal drops, low connectivity, and ensures a robust wireless experience. And then a minimum SNR, which is signal to noise ratio, is 20 dB. It ensures that the signal is stronger than the background noise. This helps in reducing signal degradation, interference, and it ensures a stable communication channel. And then we have data rate. Data rate is at least 12 Mbps. It ensures sufficient bandwidth for users. This supports the demand for various applications, including video streaming, file streaming, and file transfers, and other data-intensive applications. And then we have a round trip time of at most 200.0 ms. It ensures low latency communication between devices on the network. Low latency is crucial for real-time applications like voice call, video call, and other interactive services. And then the last one is the deploying number of access points at least. For floor 1 is 6, floor 2 is 8, and floor 3 is 8. So the quantity of the access point is to provide adequate coverage and capacity for the users. And it helps distribute the load among access points, prevent network congestion, and ensure a balanced and efficient network.
For our LAN design, this is the estimation of devices capacity on each floor. On the first floor, the total devices is 45. That is 15 laptop, 20 smartphone, and then 10 tablet. And then for the second floor, the total devices is 60. That is 20 laptops, 25 smartphones, and then 15 tablet. And then for the third floor, we have 75 totals of the devices. That is 25 of laptops and 30 smartphones, and then 20 tablets. For the coverage areas of each floor, there are not so many different of the width. And the first floor is 824 meters square, and for the second floor is 796 meters square, and for the third floor is 835 meters square. this is the floor plan of the CS2 building in KPBM. Okay, in the first floor, we have student hub, postgraduate room, simulation room, and then smart classroom, Omakayam room, and then men's prayer hall. And for the floor 2, we have BK20 to BK27. And then on the third floor, we have MK HPC, that is high performance computer, and then programming lab, information technology lab, and then also computer lab.
Okay, now we go to WLAN design. So we go to access point information. So we go to Cisco manufacturer, Cisco Tech access point, Cisco Aeronet, SSID, Cisco AP3702i. Maximum device 100, maximum speed 300 Mbps based on our testing. So the standard we're using 11N and 11A SIM. We support 2.4 GHz and 5 GHz. Okay, now for the IP address. For the floor 1, we use the default gateway 192.168.1. For floor number 2, 192.168.2.1. And floor 3, 192.168.3.1. So on the floor 1, we have 6 AP. Floor 2 and floor 3, we have 8 AP. Okay, so this is the logical network diagram, the network design, LAN design. So for each floor, we measuring. The first floor are using for 45 device, floor 2, 60 device, floor 3, 75 device. So every floor, floor 1 we use 1, 2, 3, 4, 5, 6. Floor 1 we use 6 access point. Floor 2 and 3 we use 8 access point. So by total and design, the special request and consideration. So in the design of our network infrastructure, several special requests and consideration have been incorporated to ensure optimal performance, security, and adaptability. The following key aspect has been addressed. So we just using 2 consideration or requests. So the first one is we have implemented a modular design that allows for seamless integration of new components or modules, ensuring adaptability without requiring a comprehensive overhaul. Flexibility in configuration is a key feature, allowing for easy adjustment to make changing requirements, whether it involves the addition of new user, devices, or services. So the second one is as the security elements, the security one. The primary purpose of our network design is on data integrity, confidentiality, and vulnerability protection. Strategically place the firewalls primarily oversee and control the incoming as well as outgoing traffic. Implementing security policy by denying access to unauthorized personnel, IDS or intrusion detection system, the response tools that can detect attacks in real time, prompting alerts or providing preventive measures. Security posture is being improved constantly through regular security audits and also assessment, which identify the vulnerabilities.
Okay, here we have result and analysis. Okay, now we go to signal strength and coverage. So this is for the floor 1. Analysis of the wireless network signal strength, sometimes called coverage, is the most basic requirement for a wireless network. As a general guideline, low signal strength means unreliable connections and low data throughput. So we go to the first feature, which is the before any changes. There is one access point only located in the smart classroom. The signal strength coverage is represented by the shaded areas. The green and yellow shades indicate good signal strength, while the gray areas represent poor or no signal coverage. So we can see that with only one AP, a large portion of the floor, especially the student hub and across the line room, have inadequate coverage. And then we go to the after feature. The after is the proposed floor plan. We proposed to have a multiple access point installed throughout the floor. Each AP has a green circle around it indicating the area of signal coverage. It is clearly from this figure that the signal strength and coverage have been significantly improved throughout the entire floor. With all areas now falling within the green shaded zones, that is what we're aiming for, we show strong signal coverage. So this before and after comparison demonstrate the effectiveness of adding additional AP to improve wireless network coverage. The after changes show a well-distributed wireless network that ensures comprehensive coverage and likely better performance for user throughout the floor. Okay, now we go to the next one is the floor 2 signal strength and coverage. So, for floor 2, when we do our survey, we don't find any AP. So, we propose a better network coverage and signal strength. We add multiple access points for floor 2. So, for floor 2, we installed one in each room, and then we can see a good heat map for the coverage and strength where it shows green inside the room, where that's where the important area. So because that is where we fully utilize the connection, the wireless. And for the outside room, it's still in good signal strength because of the every AP in the room. So this will significantly improve the network strength because the before proposed, maybe there was no AP because it's using the upper floor or the lower floor AP. Okay, so for floor 3. So for floor 3, this is the signal strength and coverage for the floor 3. The before one, there is only 2 access points on the right side, the stairs and inside lab. So the signal strength is good, but just in like 3 rooms only across the floor. The reason maybe it is because the other room, it was like a lab that there is full of computer. So the computer is normally connected through wired. And then for the after image, the after figure, the proposed floor plan is we add multiple access point. So we can see each AP has a green circle around it, indicating the area of signal coverage. It is clear the changes that we made has improved significantly in signal strength and coverage, because the before one, the left side on the top is a big gray area, and for the new one, we aim to have a better coverage for all around the area. So there will be many improvements here with this proposed floor plan.
In the signal to noise ratio analysis, that is SNR, it provides us with the insight into the quality of the wireless network. SNR is an important parameter in wireless communication. It represents the ratio of the power of the signal to the power of the background noise in each communication channel. And then, in context of the wireless communication, the signal is the process of information delivery, while noise is the unwanted disturbance or interference that can decrease the quality of the signal. Okay, in the floor 1, before we propose the design, the signal to noise ratio not so good, but after the propose, all the areas are covered with good signal to noise ratio. For floor 2 or second floor, before this, there are no AP in this floor, but we propose to put AP in this floor, and the signal to noise ratio are good. For the third floor, before the proposed design, the signal to noise ratio are pretty good, but we want to cover all of the areas. After we propose, the signal to ratio cover all of the area. Okay, this is the result of the signal strength of each of the access point in floor 1. Okay, the first access point is in the student lounge, because it is a hotspot for students, because many students go there to do their assignments or group work. And then at the postgraduate room, because to ease of use for the staff to do their work. And then in smart classroom, as the name is smart, it must have connectivity to the internet. And then the simulation room for the students to do their simulation for their project. And then at the middle space of the floor 1, because some of the program were held there, and it is for general use. Many people will use it. And then in Omakayam room, that is a fully equipped room. Okay, that's it. Okay, this is for floor 2, and the positions of all the APs is in the classrooms. It is because all these classrooms doesn't have personal computer. The students will have to bring their own devices and to do their assignments and work, and it will need wireless connectivity to internet. And then this is for floor 3, and the first AP is in Programming Lab 1, and then Programming Lab 2, and then also in the MK14, this is also a computer lab. And then in the right middle space, okay, in this space, students likely to do their assignments, do revision and study, because it has tables and chair at that place. And then in the MK HPC1, HPC is for high performance computer. And then in the MK HPC2, and then in the Intelligent System Information Lab, that is for student do their maybe research or project or on the lab, in the lab. And then in the left middle space, okay, this position is also a hotspot, because students also like to do revision, study, and do assignments there, because it have tables and chairs too, just like right middle space.
Okay, now we go to the network performance section, the evaluation of the wireless network performance. So this is the first one, about packet loss. So here we follow IKHAO best practices and set our aim to get 0.0% packet loss. So for floor 1 it is 0.0, for floor 2 0.0, and floor 3 is 0.0 packet loss. So this is the scale of the packet loss. Okay, now we go to the next one, latency. So this is latency for the floor 1. The heat map represents the secondary signal strength of access point on every floor of the building. So this is signal strength from IKHAO for the secondary signal strength. The heat map helps to ensure smooth roaming for clients and quality of service for certain latency sensitive applications such as VoIP calls. So this is the scale. The first floor on the left side is the 2.4 GHz signal strength. So we can see here the best signal strength should be the green, and then we go to the red. So the red should be higher latency. And for the right side is the 5 GHz. So we can see it starts from the green, the best one, and then slowly to yellow, to orange, and then gray areas. Gray areas is normally no coverage, no signal. So that is very bad. So this is for the floor 2. You can see the 2.4 GHz on the left side, the 5 GHz on the right side. Okay, and now this is for the floor 3. So this you can see on the left side is the 2.4 GHz one, and then on the right side the 5 GHz one.
Okay, now we go to network performance. So my part is network jitter. So the command prompt shown below, showing ping from the devices into access point. The jitter are being calculated by the difference on latency between 2 or 3 packets replied from the access point. So floor 1, which is with ping into 192.168.1.1, the IP for the floor 1, we identify there are 6 or 7 millisecond jitter, which is minimal, acceptable, but very minimal. So floor 2, we ping into 192.168.2.1, and we get 2 or 3 millisecond jitter, which is very good for network performance. So to the flow 3, we ping into 192.168.3.1. So we get 2 or 3 millisecond jitter. So for our network design and our proposed network, they are very performing well in terms of latency and jitters.
Okay, now this is the throughput section where the evaluation of wireless network performance. The data rate is the highest possible speed at which the wireless devices will be transmitting data. Typically, the true data throughput is about half of the data rate or less. So here we can see floor 1, floor 2, and floor 3. So for floor 1, it's optimal. It's just on the toilet, the throughput is going to be lesser because there are no AP near the toilet. And then for floor 2 and 3, we aim to have the optimal performance on every area section. Okay, so for the recommendation and conclusion, to further improve the design of the wireless network, we need to conduct comprehensive site survey. For that is we can assess physical environment and identify that what the simulation is hard to get, like a very in-depth survey. And then the second one is up-to-date technology. So we recommend WP83 Enterprise, an advanced encryption protocol, which is the latest one. It works well with our strategy and it will reinforce the defenses. So in conclusion, the WLAN project has successfully addressed the challenges of unreliable connections in the CS2 building at the KPPIM. The analysis of signal strength, coverage, and throughput across the 3 floors demonstrates the effectiveness of the proposed WLAN design. It is recommended to stay updated with the latest technology to ensure continued efficiency of the wireless network. Thank you.
Okay, that's all from us. Thank you for lending us your ears and thank you for watching.